Okay. Hello, everyone. Welcome to 5G network slicing and OpenStack. So today we're going to talk to you a bit about some research we've done, some work we've done around trying to understand how network slicing might potentially work with OpenStack and how OpenStack might fit into some sort of network slice. And so what we're going to do is we're going to talk a little bit about 5G, what it is and some of the use cases that are involved and some of the diversity in the use cases. Then we're going to talk a bit about what network slicing is. Then we're going to talk a little bit about what network slicing might be like in terms of an NFV construct, like Etsy NFV, what they're thinking about it. And then we have a demo using a Mano system called OPENBATON that happens to have a network slicing engine component. And we'll have a little bit of a demo, and then we'll have some sort of closing pieces. So my name is Curtis Collicutt. I'm an OpenStack architect at a Canadian company called Interdynamix. And I'll let Corey introduce himself.
Hi, I'm Corey Erickson. I am also an architect at Interdynamix Systems out of Edmonton.
And feel free, after this talk is over, feel free to email us. We'll put our emails up at the end. If you have questions, comments, concerns, criticisms about some of the things that we've said today, feel free to let us know. We'd always like to hear the feedback. So some of the things we want to talk, I always like to start off talks and sort of give you my perspective of what we're considering when we're thinking about these things. So we want to know, what is network slicing and how does or will theoretically it work? It's pretty obvious that it's got to be end-to-end, so taking up an entire network. So there's more than OpenStack that's going to be part of that. So how is this all going to work together? In a way, I'm sort of calling these domains. So OpenStack is a domain. There's other pieces that might be other domains. What role will OpenStack play in a network slice? And then, what features does OpenStack have now that sort of meet the requirements or could meet the requirements? And sort of where could we go from here? So to introduce 5G.
Okay, so 5G. We've all heard a lot about 5G over the last bunch of years, and as we're starting to move a lot faster in that area. So 5G promises to transform our network in an end-to-end fashion, as we've heard, as our demands on the mobile side grow. The demands on our core networks are going to grow exponentially. So there's a lot of things happening that are going to require APIs to control end-to-end. We talk about network slicing. How are you going to control a network slice in networks that you don't necessarily control or own? So we've got some off-stated performance requirements that are expected to expand our 5G capacities as we move forward. So here's a diagram that we found interesting. Most of you have seen some of these diagrams many times, and this is just a depiction of the often stated performance requirements. So the light green area represents 4G, and the darker green area is representing 5G. So as you can see, the next generation of networks are going to demand more of everything, better latency, better throughput, and essentially just more out of our networks. So this diagram represents some of the potential major use cases that will present some demands on our networks. Some of the proposed use cases are enhanced mobile broadband, which will bring us stuff like the ability to 3D stream video to our 4K, 8K mobile screens. We'll also have some networks that reliable low latency communications, which include things like autonomous vehicles, transit, air, multi-access computing. And then, of course, we've got mission-critical broadcast and alerting systems. So, as well as machine-type communications, which are our sensor networks, smart buildings, smart intersections, all of those type of communications that are going to put more demands yet on our network. So, and yet, just one more graph, which just represents what some of those demands may look like as we move forward for the major use cases.
So now that we've covered a bit of an introduction to 5G, we can see that there's some pretty diverse use cases, and often these use cases are competing, right? And that's sort of where 5G starts to the network slicing starts to come into play, is because we have all these diverse use cases, but how do we support them all at the same time how do we understand which ones are more important and should have higher priority? How does this all work together? So how do we support these diverse use cases? So I should say too that we did quite a bit of reading. So at the end, I'll give you a link to all of the documents that we read. We have a bibliography that's about 100 papers, whether they're academic or white papers or others. So we did quite a bit of reading and took some of these diagrams from these documents, and I've put the source down for each one of these. But I like this. Well, this is one of my favorite diagrams that we came across because it not only indicates that we have multiple slices, including all the way down to a phone, but it also shows that the places where OpenStack would participate in this entire slice, right? So we see a core cloud depicted, and we see an edge cloud depicted, and those are places where OpenStack could be involved in this entire network slice. Having done all this reading, we realized how many organizations are involved in creating, what 5G is and what 5G network slicing is. So every single one of these standards bodies and groups has some sort of opinion on what network slicing should be and what it should look like. So some of them have more influence than others, but they all have an opinion of some kind. So having done all this reading, I pulled a whole bunch of quotes out, and it was, Corey and I had to fight a little bit for me to because I had 5 pages of quotes that I wanted to put on here, but we managed to just bring it down to a couple here where, obviously, where we pull out all this information, and one of the things is that, this is an end-to-end logical network. Like a network slice is some sort of end-to-end virtual network or logical network that rides on top of a physical network, and they're all co-located on the same physical infrastructure typically. The reason we have the second quote in there is because of the cross-domain portion, right? So we could not only see network slices be made up of different devices and different clouds, but also potentially different operators. So we could have multiple operators that are participating in a network slice. So through all these documents, we pulled out a few of the major requirements that that were pretty much in every one of these documents, right? So I mentioned end-to-end a couple times. We need to orchestrate these network slices. They need to be on demand. We need to be able to create them and destroy them dynamically. We need to be able to give them additional resources and take them away. They need to be extensible. We need to be able to add different features and capabilities to these systems. And because they're virtualized, because they're logical, we also need to make sure that one slice can't interfere negatively with another slice. So we need things like safety in terms of failures, safety in terms of protection. We also need the ability to do some sort of hierarchical model for these, AKA recursion, where we could build a slice out of a section of another slice, right? And to me, that's one of the big things that I'm having some issues determining how that might work in OpenStack, where we want to be able to build network slices from pieces of other slices. Isolation, flexibility. We need to expose APIs and slices to potential third parties, to other operators, to other services. Cross-domain again. And not just OpenStack deployments, but also switches, routers, anything that can make up a network, right? And all that and a kangaroo. This is one of the diagrams that I found that I thought was kind of funny because there's a kangaroo. So now that we've talked about 5G a little bit, we've talked a little bit about what network slicing is and what some of the requirements might be. We also want to consider how network slicing might work in NFV, in network function virtualization. Like, how are these two things going to work together? Because from a high level, network slicing is not necessarily not defined by network function virtualization, right? So network slicing is not part of etc NFV at this point, right? So how are these two pieces going to work together? So this is discussed in a few documents, but I pulled one pull quote out of there. But so in order to do network slicing, we're probably going to need NFV because we need to build virtualized network functions and make them part of a network slice. And typically that might also involve using some sort of SDN as well. So in order to do network slicing, we don't have to have NFV, but we probably will. In order to do network slicing, we might not have to have SDN, but we probably will. So this is another diagram, one of the diagrams that I like that we came across. I like this one because we see that there is a VNF that is part of an actual slice, right? So network slices aren't just like most of us are probably familiar with like a VXLAN based network, like a layer 2 network in OpenStack. There's more to a network slice than just providing some sort of virtual network, right? Like we could also put a VNF or a series of VNFs in a chain that make up a part of a network slice. And so that's why I like this diagram, because it depicts the slices, but it also shows that network functions, can and will probably be part of a network slice. So a lot of the people in this room have probably seen this diagram many times. I just wanted to put it up here for reference in case there were people who hadn't seen it. But in the typical ETSI diagram that we have here, we have the NFVI and the VIM, which is typically the part where OpenStack lives. And when we're thinking about where we want to put network slicing, there's a document, the ETSI-GR NFV EVE 012, that sort of gives us an idea of where a network slicing engine might fit into, right? So something is probably going to control network slices, control their creation, and all those different requirements that we mentioned at the beginning. But what is that thing? And in this document, they're suggesting that there's some sort of network slice manager, network slice engine, and separate components that live outside of the NFVI and the VIM. And maybe the orchestrator talks to those functions. So this is just a bit more about this particular ETSI document that talks about how network slicing might fit into NFV. So according to this document, as of this time, there's no common definition of network slicing, but it's probably safe to say that we can feel like in terms of NFV, it's a resource-centric view of a network slice, right? So there's a potential, it doesn't have to contain a VNF, but if it does, then it's like a piece of, the NFV becomes a piece of the network slice. This is another interesting component. So again, there's not necessarily a strict definition of what network slicing is going to look like. And I think this diagram is particularly interesting because there's multiple SDN controllers. So often we think of SDN, we think of there's one thing that's controlling the network. But in this diagram, they're suggesting that there could be multiple instances of an SDN system. So each network slice potentially could have an SDN controller of its own. So when we're creating these network slices, we might actually be instantiating multiple SDN controllers to do this. And I'm not sure if that's how it's actually going to work out, but if it does, that's a kind of an interesting model, right? Like where how can we instantiate multiple, not only slices, but SDN controllers per slice, or how is this going to work?
Okay, so OpenStack and network slicing. We're going to talk a little bit about what OpenStack brings us today. So today OpenStack provides some of the key components that we're going to need if we're going to look at network slicing with OpenStack. So we've got isolation, multi-tenancy, management APIs. It's cloud native, elastic and flexible. OpenStack's become the de facto VIM, the de facto standard API for the VIM in the marketplace. It also brings us the ability to do multiple SDN integrations, so we can have multiple clouds with different SDNs in place. So emerging trends, edge computing using OpenStack. We're hearing more and more and more about OpenStack on the edge and how that's working. So and there's also multi-cloud management. So here's a list of some of the related projects, related OpenStack projects, features, specs that we found interesting and will very likely play a role in a 5G network of the future. So Curtis can talk more about some of these in a moment as we move forward. So the network slicing demo coming up in a moment is going to demonstrate launching a simple Ubuntu-based VNF and utilizing the NEUTRON QoS features. So we focused on that.
So we saw a pretty big list. I'm just going to hop back to this one for a second. This is not necessarily an exhaustive list either of all the different components or projects or specs in OpenStack that could be very useful in network slicing. One of the ones that I think is probably more important right now is the work that's being done on the Nova placement API, where this placement API is going to be a place where you can put inventories of resources that we have available in the cloud, and not just like compute storage, but also like networking. And almost, my impression is that almost anything will be able to track in the Nova placement API. Eventually this will get broken out into its own system. It'll get broken out of Nova and into its own separate component. Also, Jay Pipes, one of the a prominent sort of developer in OpenStack, has said that NFV stands for never-ending feature velocity, as he's doing his work on this Nova placement API. Group-based policy. Group-based policy is a pretty fascinating project that provides like a declarative abstraction, right? So group-based policy has actually been around for quite a while. I don't know how much use it's gotten, but it's actually a very interesting abstraction in terms of how people can use and create network resources in OpenStack. It's also based on sort of a network service chaining concept, and I think this would be more at a layer 3 sort of network service chaining concept. But it's kind of fascinating that this kind of capability already exists in OpenStack and could potentially be adopted in a network slicing context, right? So it's pretty interesting that this exists already. NEUTRON RBAC, so I don't know how many people are familiar with this, but it's actually possible to share NEUTRON objects with multiple tenants, right? So this is actually a pretty fascinating capability in terms of that you can create a network or a quality of service policy and you can share it through multiple tenants, right? So often in OpenStack we sort of had this like, admin or not concept, right? But in this capability, with this capability, we kind of start to get this hierarchical, recursive, capability where we can share, we can create groups and share things with multiple tenants, and it's not just admin, not admin kind of concept. So RBAC is pretty fascinating. So there's a couple other projects that I think are related to network slicing. The NEUTRON Common Classification Framework, which is being worked on right now. There's a spec, provide a link. But there's a whole bunch of different projects in OpenStack, such as networking SFC, firewall as a service, and a couple others that actually classify traffic in some model, right? So what if there was a centralized place where we could use to classify traffic, right? And then obviously that would be pretty useful in the in the context of network slicing. There's also work being done in terms of network-aware scheduling, where we could, instead of just scheduling based on compute storage, we could also schedule based on networking. So this is mostly focused around like a rack-aware concept, but it could potentially be used for other models of scheduling as well. And then probably the most important one, and the one that we're going to use today, is NEUTRON quality of service. So currently, you can build quality of service policies. You can apply them to ports and networks in NEUTRON. And right now, there's basically two different ways that you can apply quality of service. One is with egress bandwidth, and the other is doing DSCP markings. So we've talked a little bit about the fact that we're going to use OPENBATON and its network slicing engine, and that engine can use the bandwidth limitations to apply quality of service to a port. In the future, it seems like has been some mention of being able to do minimum bandwidth as well, but that's a little bit trickier because you need to be able to schedule things, right? So the scheduler would have to be aware of of what resources are available. My background isn't necessarily strictly networking. I'm not like a classical networking person, but my impression is that in general, a lot of times, sort of network engineers might consider quality of service as something that's a pretty difficult problem and maybe in some ways not solvable. But I think given the fact that we would control a network slice from end to end, there's definitely the potential to actually be able to do some quality of service. So in this example, we're going to do what we said we're going to do, which is talk a little bit about OpenBATON and then show a demo of actually having it apply quality of service policy.
Sure. So here's a diagram that we found from the IEEE that indicates a placement of network slicing engine, in relation to the Mano and the Vim. In this case, OpenStack and OpenBATON. So you can see where that fits in there. And here's another interesting diagram that we found that represents an end-to-end network with multiple network slices that may require QoS and possible service function chaining to deliver the demanded service or function. So you can see the slices carrying through the network there. So interesting note, when we were looking at the source code of OpenBATON, trying to get it up and running, we actually found that the QoS policies were hard-coded into it. And it shouldn't be hard to change that, but it was interesting to find that we couldn't dynamically define what the QoS policies were with OpenBATON.
Yeah, and maybe I should take a second here to say that that OpenBATON is a reference implementation of the Mano structure. So it's not necessarily meant to be like a full Mano that maybe you would use in production, but I think the value, and we'll get to this more, but the value of it is that it's quite small in terms of its code base. So when we were working on this, the documentation actually said that the way that you utilized it was to use a minimum bandwidth, but then we could actually just go, and it was incorrect, so we could actually just go into the code and read the code and find out what the right way to specify it is. And then as we were doing that, we noticed that we have different quality of service values that are hard coded, including one called coal, which I like a lot.
Yes, and while Curtis likes coal, we're actually going to focus on using the bronze policy in our demo here. So, okay, so very simply, I'll just go quickly over the demo before we get to it. But we're going to use OpenBATON to instantiate a single VNF into our OpenStack instance. The VNF, the VNF descriptor has been predefined with the QoS policy requirements, so everything's in place for us when we launch the VNF. So the VNF will then register with the network slicing engine and receive a notification. The notification will include those QoS policy requirements. And then the network slicing engine will ensure that the QoS policy exists in the cloud, and if not, it'll create it. So, and then of course the policy will then be applied to the VNF's port. So, see if I can get this right without too much trouble. Find my. There we go. Okay, so in the top left corner we have the OpenBATON logs. Bottom left corner we have the network service slicing engine. We're going to launch the VNF using OpenBATON's web interface. And this will make its API calls to the OpenStack API, create our instance, which we'll see in a moment here. So we see on the bottom right-hand corner, we see now we have an OpenStack instance there. There's no QoS policy there, but if you see on the top right-hand corner, we're listing out the policy on the port that now exists, and those policies are 0. So QoS hasn't quite yet taken effect yet because it doesn't know what to apply. We still don't have a policy in our cloud yet.
So we got an 8 times speed up here. We're just waiting for the VNF, the EMS, the element management system on the VNF to come up, and then it's going to register. The network slicing engine is going to see it, and then we should see eventually the policy created.
So, and there we go. The policy has just arrived, and we can see that the policing burst rate and has now got a number attached to it. So that's based off the bronze policy that has come through.
So this is a fairly simple use case. We just have one VNF. All we wanted to do was show that a quality of service can be applied to a particular port once the VNF comes up. You could imagine if we had a much more complex network service that had multiple VNFs coming together, and we could apply the same quality of service policy to all of them. And yeah.
So yeah, that brings us to the OPENBATON lessons learned. So we had some issues with the OpenStack for J plugin and wound up having to compile from source. It actually turned out that OPENBATON, as Curtis mentioned, is a reference implementation. It comes with a bootstrap script, so you can get it running in your lab fairly quickly. However, we found that our best success was to download everything and compile it from source and make it work that way. So. Yeah, one of the positives, the code base is very, very small. So if you want to get it up and running in your lab, modify it, we'll work with it for your purposes. It's fairly small and easy to get a handle on.
So overall conclusions from what we experimented with. So as I mentioned, I have some questions around how we're going to do like hierarchies and recursion, which seems to be a requirement of network slicing. I mentioned that we could potentially have multiple SDN controllers involved, so each slice could possibly have a network or an SDN of its own. There's only two current quality of service mechanisms, max bandwidth and DSCP. It would be really interesting to be able to schedule based on network resources. One of the big questions I have too is around monitoring, right? So we know that network slicing has requirements for some pretty serious performance requirements, or sorry, 5G has some pretty serious performance requirements. So how are we going to understand, where is jitter happening in the network, in a network slice? How much latency is actually being utilized in a network slice? How are we going to figure these things out? I talked a fair amount about group-based policy. I think it was ahead of its time. I don't know how much use it's actually gotten. I'm curious as to where it is now, and I would like to see how it could potentially be applied to network slicing. Like maybe there's a potential to modify or add some features to group-based policy to make it capable of doing network slicing. Multi-cloud management. So we have regions in OpenStack, but that's basically, for the most part, just the ability to share Keystone and Glance. So how can we have multiple OpenStack deployments and be able to connect them together network-wise, right? Like how can we, and not just connect them together, but have them understand, how to have them be able to talk to one another and have some sort of understanding as to what's going on there. We also have done quite a bit of research into the current state of service function chaining. Service function chaining is kind of fascinating because in a lot of ways you can just make packets appear on interfaces anytime you want, right? Like, so we could build almost any chain and just drop packets wherever we want. And if we can do that, then it's almost too flexible, right? Like, how do we monitor that? How do we manage that? I have quite a few questions around that. And then, of course, one of the bigger ones is this third-party stuff. Like, how do we have like third parties and external operators? How are we going to give them access to these network slices and management APIs, and how are we going to manage those? Like, would a third party who has a network slice also need access to OpenStack APIs? If so, like what would that actually look like? I mentioned network service function chaining. Like how if we do service function chaining as part of a network slice, how do we troubleshoot that, right? Like, so do we need some sort of path tracer? What kind of functionality would we need to be able to troubleshoot a network slice if it's using service function chaining, right? Orchestration, like the definition of orchestration in some of these documents is the continuing process of selecting resources, which kind of suggests like online scheduling, right? Like we don't really do that. When we schedule a resource in OpenStack, it's like a one-time thing. Like, so if orchestration is continual, what does that actually mean? How can we do, if we need to, how do we do online scheduling when a resource has already been scheduled? Can we move it around? Can we do, what does that actually look like? As we mentioned, we did a ton of reading, and I'll show you the bibliography or the link to the bibliography at the end. but they're all pretty high level, right? Like there's very few, maybe 1 or 2 out of 100 that discuss how you would actually apply network slicing in a real world environment, right? So that's a bit challenging. I mentioned intercloud networking already. But also, like, I think something that I've sort of have glossed over in this presentation is that there's a lot of features that in OpenStack that already exist. And in some ways we take for granted, right? We have the ability to create virtual networks and virtual routers and virtual ports and, create isolation using them in some capacity, whether it's VXLAN or some sort of encapsulation. But overall, like, there's all these great places to do work and create, good support for network slicing. So to end this off, I have 3 potential solutions, scenarios, and these are just sort of me thinking about like where could we go from here, right? So these are not necessarily statements of fact, because at the bottom you can see I actually put that these are not statements of fact. So I'm just kind of thinking about like where could we go. So potential scenario number 1 is like we just continue on sort of what we're doing now, right? Like that everything's fine. OpenStack is growing in terms of NFV, but it doesn't really necessarily need to have a concept of network slicing, right? So we just kind of move forward based on that concept where OpenStack doesn't need to know about network slicing, right? We just build network functions, and maybe an SDN manages a lot of the networking that we need for service slicing or network slicing. We monitor KPIs with third-party tools. The SDN probably provides a lot of the metrics. Most of the components could be outside of OpenStack. The orchestrator would take care. The orchestrator would be the main thing that really does most of this work. If we really need to do this sort of recursion and hierarchy and additional quality of service requirements, maybe it's just too much work, right? It's just too costly, and maybe nobody wants to do it. And maybe there's other things that we should be focused on in terms of upgrades in OpenStack, stable versions or stable releases and things like that. So that's one possible place. The next scenario could be that we do, OpenStack has some concept of network slicing, right? So we could improve the quality of service features that are available. Maybe we could do network scheduling based on minimums. Maybe OpenStack has some sort of concept of network slicing. Perhaps it's based on networking SFC, the project networking SFC, or group-based policy. Have we do some sort of work there to improve things. Also, I mentioned, how do we monitor all this? But maybe we can have an API that deploys network probes, right? So I'm a big fan of the Octavia load balancer project, which actually creates virtual machines that act as load balancers, sort of in its kind of a self-hosted concept, right? Maybe we could do the same thing with network probes. Potentially the edge model really gets moving, and we can start to pull in some technology from some of the requirements that are happening there. And then maybe we accept in some ways that OpenStack's best fit might actually be in the telecommunication industry, right? And then scenario 3 is just OpenStack has network slicing becomes like a first-class citizen, right? So maybe we get our own project that is a network slice manager. We dial quality of service up to 11. Maybe we could do online scheduling in some capacity if it's actually really required. Maybe we have the ability to build out sub-APIs and really make the permission systems more capable of allowing third-party systems and external operators and so forth. So that concludes this part of the presentation. So thank you very much. I did put a bibliography up there. I have to go through it and make some corrections, but we put every single paper that we found in that bibliography. You're free to email us if you have questions or comments. Special thanks to the OPENBATON team. It's a really nice piece of code that is a reference implementation, and you can put it in your lab, and it doesn't, you can run it on an 8 gig VM or something like that, or even smaller. And with that, I'll open it up to questions.
Fantastic presentation, I would say. And number 2 option and number 3 option, I think we can start with 2 and go towards 3. That's my thinking right now. And I should appreciate the, the Fraunhofer folks of OpenBATON, Giuseppe Carella, I think, and his team. They are a great team, and they really have done a great job. And for you, you have dug the entire, I think, it's like finding out from Bible where is what, almost. Very good.
Thank you.
On the scenario 2, I have a question for you. Specifically, I don't know, GBP, group-based policy, Sumit was there, I recollect, in quantum. That's the time when we started on group-based policies.
Yeah.
If he's around, I don't know. But certainly there, the question comes, when you talk about policy being common for the group-based policy is end-to-end. You have a contract, and you apply the contract, and you apply the policy. The policy in itself, when you apply to virtual network, so are you saying the policy is common, or are you saying that, like you said, admin and no? That is admin or none.
Yeah.
That is the way you share, right? If you share as admin, you share with everybody, or you don't. But here you are talking about a tenant and another tenant. Two tenants sharing common policy, or is it the policy itself such that both the tenants can see each other's, share each other's limited, whatever scope limited?
Yeah, I think that. So first off, we have a lot of work to do in terms of understanding what group-based policy is. So I'm going to be really honest with you that we didn't do a lot of research into actually how group-based policy works. But from like a high level, it seems to me like a really good abstraction to use in terms of building some sort of network slicing capability. But I think that your almost question is like more like the NEUTRON RBAC stuff, right? Like I think yes, we would absolutely, if we had an object that was a group-based policy of some kind, we would want to be able to share that with multiple tenants so that we can do like the recursion and hierarchical, meet those requirements as well. So I think absolutely, yeah, we'd want to be able to share those with multiple tenants or no tenants if, like.
Okay, I see,
yeah.
I see. So you're saying that here, because of the hierarchical requirements, you can have multiple VMs as a bundle, and then one can share the other's resources.
Yeah. Yes,
across.
Yeah.
The other portion I want to know, you have radio network, you have got the core network, or then there is a mapping between the slicing on the radio side versus the core side. Do you have any thoughts on the mapping? Like in the carrier domain, we have got interactive burst traffic, like we have DSCP and all that we do in the. Is there anything like that mapping you have seen in any of these?
No, not yet. No,
Not yet.
I don't have. So even though I talked about multiple domains, we really only considered the OpenStack domain. Like currently the OpenBATON network slicing engine can only work with NEUTRON. Mm-hmm. But if we added some code to it, then it could talk to anything, and we could start to like do multiple domains. But we didn't actually approach that in this presentation.
And
yet.
what version of OpenStack OpenBATON used?
Well, like the master.
Master. Okay.
Yeah, we had to compile from master to get quite a few things to work. Yeah, absolutely. Yeah, but
fantastic, absolutely fantastic job, and I think people must clap for you.
Okay, thank you very much. Do we have any other questions? Sure.
I don't know if it's so much of a question, but some comments. I think a hybrid of all three of these things are quite insightful. Jeff from Limited Networks. Coming from the Open Daylight standpoint, and ONAP and some of the other projects, you've got your finger on exactly some things that need to happen from an OpenStack project perspective, regardless of what the long-term view is.
Yeah.
Like having quality of service as a first-class citizen, having this concept of slicing as a use case of quality of service, these types of things are mandatory when we talk about things that are effectively, network namespaces and intrinsically shared elements, in order to really meet carriers' SLAs. And indeed, I would say, let's not be down on OpenStack, that there are certainly large enterprises that have these same kinds of requirements and internal SLAs, whether they be federal or financial or what have you. But absolutely finger on the trigger in terms of service function changing. Maybe group-based policy as well, but especially that QoS, resource reservation and things like that, mandatory for these use cases. So even if there is an overarching orchestrator, even if it is overarching Mano that is handling creation of things, these are critical components for the community to work on here.
Great, thank you.
Thank you.
Okay, well, thank you very much. We'll see you around.
Thanks, everybody.